know most people are done. If you're not quite done, it's not the end of the world. So, 15, 30, 60, 120, and 240 being broken down into a product of their primes. Now, the first thing, before we actually break things down, I want to recognize is, what do you notice about this sequence? It is multiplying by 2 every single time, making it a geometric sequence. And this multiply by 2 every single time is what? What's that thing that we multiply by every single time called? Not quite constant difference. Close in idea. It's the constant ratio. A constant difference is an arithmetic thing. Geometric is constant ratio. So R is 2 in this case. Okay. Now that's going to be some important features between the purpose of this warm-up. Now, 15 is the a sub 1, 30 is the a sub 2, 60 is the a sub 3, 120 is the a sub 4, 240 is the a sub 5, and we could go on forever. Now, to the actual thing that I had you do as a part of the warm-up. 15 is what prime numbers getting multiplied together? 3 times 5. What about 30? 3 times 5 times 2. Which, if you recognize 30 as 15 times 2, that should make sense, that it's 3 times 5 times 2, because 15 times 2 is what gave us the 30. 30 times 2 is what gives us the 60. So 60 is 3 times 5 times 2 times 2, or 2 squared. I'll come back and I'll write that version of it in a bit. 120? 3 times 5 times 2 times 2 times 2. And 240, 3 times 5 times 2 times 2 times 2 times 2. In a prime factorization form, we would write this. The first 2 wouldn't change. And then, as was stated earlier, I could have written this as 2 squared. This one has 2 cubed. And this one has a 2 to the power of 4. Now, overall, pattern we should see through this process is that every term in the sequence is going to gain another 2. Or, in this form, the exponent on the 2 increases by 1 every single time. Because this is technically has an exponent of 1. And this one technically could have a 2 to the power of 0. We're getting there. So, essentially, what's happening every single time from term to term is it's getting multiplied by an additional r, and that r is the 2. So this first one is 5 times 3 times r to the 0th power, because r is 2. The second one is 5 times 3 times r to the first power. 5 times 3 times r to the second power. 5 times 3 times r to the third power, etc. Now each of them has this 5 times 3 in common, and that 5 times 3 comes from a sub 1. It's the first term in the sequence. So, a sub 1 is equal to a sub 1 times r to the 0th power. And that's shouldn't be overly shocking. Anything to the 0th power is 1. I can take any number and multiply it by something to the power of 0, and it doesn't do anything. A sub 2 is a sub 1 times r to the 1st. A sub 3 is a sub 1 times r to the 2nd. Following this pattern, for this one, a sub a would be equal to a sub 1 times r to what power? Not quite. 5 has a 4, 4 has a 3, 3 has a 2. Yeah, 79, other direction. So, a sub n is equal to a sub 1 times r to the power of, this is n, so n minus 1. This is the formula for a geometric sequence, which is what we're getting into today. 10.3, technically day 1, I forgot to write day 1. It's geometric sequences and series. We are going to be focusing in on the sequence side of things. So, we went through that in order to take a look at this formula, in order to see what the formula for a geometric sequence is. Now, this is the geometric sequence explicit formula. Much like with arithmetic, this type of sequence has two formulas. It has what's known as an explicit formula, the one that you can actually plug numbers in and figure out random terms within the sequence. And then there's a recursive formula, which will break it down as the pattern itself, which we'll talk about later in the chapter. So, our explicit formula, a sub n is equal to a sub 1 times r to the power of n minus 1, has 4 variables, which we should be familiar with by now. But I always redefine them. A sub n stands for
nth term.
Technically, it's the nth term. It's that thing that gets equal to the equation. Technically, it's equal to the expression that gives us the things, but that's what gives us that equation. A sub 1 is the first term. R is the constant ratio, that thing we're multiplying by to get from one term to the next. And n is the, no, starts with a P. It's the position. I'm like, come on, somewhere in there. How many letters do I need to write?
All of them.
Apparently. No, actually, I stopped at O. People knew. Once I got to O.
Second O.
Yes, the second O. Okay, so N is the position. Tells you where in the sequence you are with the A sub N term. So, when it comes to these problems, you're going to see questions that look just like the questions you've had over the last 2 days with arithmetic sequences. The only difference is the type of sequence I give you. The only difference is that I'm going to give you geometric sequences now. Now keep in mind, I've been mentioning this for a few days. I can mix the sequences together. So you have to pay attention to what you're being asked. So, one of the things you've been asked to do is to find an indicated term within a sequence. And then they'll give you some information about the sequence. Sometimes they'll give you values in the sequence, like this. Other times, they'll give you different pieces of information. Now, the first thing you need to get in the habit of doing is checking your sequence. How is my sequence either increasing or decreasing? In this case, it's multiplying by 2. Now you need to check that first because how that sequence is changing from term to term is going to tell you what type of sequence it is. If it's multiplying by 2 every single time, arithmetic, geometric, or neither? Geometric. Multiplying or dividing is geometric. So, geometric sequence. Now, in order to find an indicated term, when I'm talking about an indicated term, I am looking for an a sub n. That is what I'm looking for. In order to find an a sub n with a geometric sequence, I've got this formula here. I need a sub 1, I need r, I need n. What is a sub 1? First term? 3. What is r? 2. R is the thing we're multiplying by every single time. N, they gave it to us flat out. 15. So, a sub n or a sub 15 technically is equal to a sub 1, 3, times r, 2, to the power of n minus 1. 15 minus 1. Now, in order to find this, the biggest issues that I see with this is people following order of operations incorrectly. Order of operations starts with parentheses or groupings, technically. There isn't something that's grouped in this problem. The exponent is grouped. If you're going to go through and do this in pieces, that piece absolutely has to go first. If you're going to go through and type this into your calculator, you have to be careful to make sure the calculator does that first, because the calculator will not always interpret it that way. In fact, if I went to type this into my calculator right now, as it was originally written, 3 times 2 to the power of 15 minus 1. Now this calculator's fancy and holds it up into the exponent. But if I had done it on this one, that's a little less fancy, it would have put it to the power of 15 and then subtracted 1 from the entire thing. So if you're going to type it all into your calculator, you either need to put this piece in parentheses, or how hard is it to just subtract 1 from a number? Not hard. I just subtract the 1. The second thing that I see people do in order to shorten typing it into their calculator is they do the 3 times the 2. Again, PEMDAS. Do you multiply or do exponents first? Exponents. You need to do the exponent first. So do not multiply 3 times 2. This is absolutely not equal to 6 to the power of 14. Think I've seen this a time or 12? Yeah. But seriously, we can just type this into our calculator at this point. We don't have to do all of it in pieces. We just need to make sure that we're not putting it all into the calculator incorrectly. 49,152. Okay, first thing you gotta look at is what's happening from term to term. Leaf, do you notice the pattern and what's happening here? Okay, now, some people don't, and so I want to address that as well. So, forgot to, I meant to. It is not taking the square root. When it comes to these patterns, overall, for the most part, we're going to be working with arithmetic or geometric. So for the most part, you're going to focus in on adding or subtracting things. Or multiplying and dividing things. Sorry, I meant to say all four. Now, if you look at the problem and you notice that things are not even close to evenly spaced, it is not adding or subtracting. So you then need to look at multiplying and dividing. Now, sometimes that's easier than others. But remember, geometric sequences are technically going from one term to the next, multiplying by something, and that's going to be an important thing. Now, when the number's getting smaller, does it appear to be multiplying by something that's a whole number? No. In order to figure out what it's multiplying by, multiplication is moving from left to right. What if I wanted to go from right to left? What's it going to do? Going the opposite of multiply is to divide. Divide, and you'll figure out what you're multiplying by. Divide the other direction. If I know it's multiplying to the right, I have to know it's dividing to the left. So I'm going to take a term, and I'm going to divide it by the term before it. Now, it's not always going to be the nicest number, and putting 0.1 on there is going to be a problem. You need the fraction form. Do you know that your calculators can simplify fractions? On the TIs, it's math, enter, enter. On the Casios, it's the little F to D button. On the little TIs, you're going to have the issue if the fraction is bigger than 1. It works, but there's a little F to D button there as well. If you have issues with that, ask me during work time. So, 1/9 is what it was multiplying by. If I'm trying to figure out multiplication this way, I do division this way. So, if it is multiplying by something every single time, that makes it a geometric sequence. Now, I emphasize that it's a sequence because on top of mixing arithmetic and geometric, we are going to be mixing together sequences and series. Okay, I'm trying to find the indicated term. I am trying to find a sub a. In order to do that, I have this formula. That formula requires knowing, I'm trying to find a sub 1, n. I need to know a sub 1, I need to know r, and I need to know n. Addie, what's a sub 1? Good. Logan, what's r?
1 9.
Good. Faith, what's n?
8
Yes. Where'd you get the 8 from?
from a sub 8.
Yes. If it's a sub 8, that means a sub n is equal to what we're looking for when n is equal to 8. That's how that is interpreted. So, a sub 8 equals a sub 1 times r to the power of n minus 1. Now again, we have to be careful of how we type this into our calculator. I first off recommend just doing the exponent before typing it into a calculator. 8 minus 1 is 7. Can you put it into the calculator? Yes, with parentheses is a requirement. There's also parentheses required a second time here. If r is a fraction, it needs to go in parentheses. Otherwise, you will only put the denominator to the power. Now, to be honest with you, you'd get the same thing this time around because the exponent would only go on the denominator, but the numerator is 1. 1 to any power is still 1. But if the numerator is any other number, you got a problem. Okay.
0.0000152
Scientific notation. Not so friendly. Remember, when it's in scientific notation, that's when the E shows up. A negative tells us it gets smaller.
So it's 4 more decimals.
You move that decimal place 4 times, so there's 3 zeros in this case. Because if I move that decimal 4 times from where it's currently located, it'd go here and then jump over nothingness 3 times. Now that being said, you can write it out that way, or you can write it out as the fraction, which is what I prefer. Make the calculator, put it in fraction form. If the calculator won't change it into a fraction because it's too tiny, then go ahead and write the decimal, but be careful. Do not write it in scientific notation. You might be asked to write an equation for the nth term. Now to write an equation, remember a sub n and n both stay variables. The first thing you do need to look at is you need to look at what is the pattern, because you do need to verify what type of sequence or series it is. This is a sequence. How do I know it's a sequence? It's a list of numbers with pattern. A series would have them added. Lindsay, how am I going from term to term? You're multiplying by -8. Now, Again, if you're struggling to see it, because some patterns are easier than others, first look at how the numbers are increasing or decreasing. Do they seem to be increasing or decreasing by the same amount every time? Then look arithmetic. See if what we're adding or subtracting. If the amount they're changing seems to differ, you're looking for multiplication. To figure out what you're multiplying by, divide terms going the opposite direction. Now, 2 divided by a negative 1/4 is not the easiest thing to do. It's not terrible, but it's not the easiest. You don't have to do the first 2 terms. We could have done negative 16 divided by 2. And then just verify that that's what it's doing every single time. And it is indeed multiplying by negative 8 every single time. Multiplying by the same thing, it's geometric, it's a list, it's a sequence. Writing an equation for the nth term, I don't need a sub n. I don't need n, those stay variables. I need a sub 1, and I need r for geometrics. Brooke, what is a sub 1? Good. Shelby, what is r?
Negative 8.
Yeah, it's the thing we're multiplying by every single time. So, the formula for geometric says a sub n is equal to a sub 1. Now, when you write out these fractions, you need to get in the habit of writing your fractions top over bottom, not at the angle. The angle, when you're just saying something is equal to the fractions, just perfectly fine, but in an equation where you've got more things going on, it makes it a little convoluted. So, a sub n equals a sub 1 times r to the power of n minus 1. Now, earlier I stated that when you have r as a fraction and you're putting it into your calculator, you need to put it in parentheses. The same goes if r is negative. When you're writing the equation as well, if r is negative, it needs to go in parentheses. I should also have a time symbol here. Otherwise it looks like minus. Now technically the parentheses takes care of that, but a negative r needs parentheses. Now if they give you the equation, the pattern, it's pretty darn easy to write the equation. It gets a little bit harder in cases where they give you other pieces of information. Like a sub 5 is 486 and r is negative 3. Now, one of the things I stated before is the first thing you have to recognize is what's the pattern going on. But if I don't give you the pattern, you can't recognize the pattern. You still do need to actually have a way to check if it's arithmetic or geometric, though. Sometimes it'll be given in the instructions. I didn't give it in the instructions. I just said write an equation. Other times it's given in the information that was given to you, such as the pattern you find. In this one, how can I know if this is geometric or arithmetic? If it says R or D, am I giving you a ratio or a difference? I gave you a ratio. That's a geometric thing. And it is a sequence because I'm asking for an equation of the nth term. Okay. In order to write an equation for a geometric sequence, I need a sub 1, I need r. R was given to me. I don't know why I'm rewriting it out right now, actually. A sub 1 I need to find. In order to find it, I have to plug in what I know. My formula says a sub n equals a sub 1 times r to the power of n minus 1. I know r. That one's easy. A sub 5 is 486. Again, the interpretation of this notation means that when n is equal to 5, a sub n is equal to 486. So that's 486. A sub 1 is what I'm needing, it's what I need to find, and n is 5. I need to solve for a sub 1, so I'm going to simplify some things first. If I'm going to simplify, this is the stuff that gets simplified. I first do the subtraction. Then I do the exponent, but I already stated something that is required in a situation like this that I didn't do. What am I missing? Parentheses around the r. When r is negative, it needs parentheses. When in doubt, just put r in parentheses all the time. When I put this in my calculator to simplify this piece, I better put parentheses around it, because negative 3 without parentheses to the 4th power is negative 81, but in parentheses is positive 81. Makes a difference. 486 equals a sub 1 times 81. To undo times, we divide. A sub 1 is equal to 6. So to write my equation, remember when you're actually writing out the equation, a sub n stays a sub n. You no longer put the 486 there. N stays n. You no longer put the 5 there. A sub n equals a sub 1, we just found to be 6, times r. We stated that was negative 3. We put it in parentheses to the power of n minus 1. Now, one of the things I meant to address but didn't address when we wrote this initial one is geometric equations will not simplify. You cannot go multiplying these because the exponent is in there first. Nothing simplifies once I plug it in. It's not like the arithmetic sequence equations where you have to simplify them. The geometric ones, you plug the numbers in, and that is as simple as it gets. Now there's one more thing you're going to be asked today. One more type of equation or question. And that's going to be about the geometric means. And we talked about arithmetic means the other day. An arithmetic mean is numbers, missing terms in between two non-consecutive terms of an arithmetic sequence. Geometric means, same idea. They're missing terms. There's what happens in the meantime between two non-consecutive terms of a geometric sequence. I'm going to need a little more room than that, so I'm switching pages. You're going to see questions that will ask you to find the geometric means between two values, much like we did with arithmetic. You don't know which of these two numbers comes first. You put one at the beginning, you put one at the end, you put the missing spots in between. With geometric, I highly recommend you go from the one that has the smaller digit. You're going to save yourself some of the fraction-y pieces of things. Is it terrible to do the fractions? No. Do we like to deal with fractions if we don't have to? No. So I'd recommend you put the smaller number first. There's 3 missing spaces between that and the last one. We then make some assumptions. We make the assumption that this 2 could be in the first spot of the sequence, therefore being a sub 1. And if that's a sub 1, the 1250 is a sub what? 1, 2, 3, 4, 5. So we're calling a sub 5 1250. Now you have to remember, when we write this, that means that when n is equal to 5, a sub n is equal to 1250. We need to know that notation. And I have my geometric sequence formula that I plug into. 1250 equals 2 times r is what we're missing here. Because if we knew how to get from one term to the next term in the sequence, I wouldn't be doing a whole lot of work. If I knew it was doubling every time, I'd say, well, that one's 2, that one's 4, that one's 8, that one's 16, 32. No. So r is what we need. If that's 1250, n is 5. I simplify what I can. The 5 minus 1 becomes a 4. Go to solve. Divide by 2. 625 is equal to r to the 4th power. Here's where people tend to get stuck. To get rid of a 4th power, I take a 4th root. Now you have to be careful about introducing roots to problems. We talk about this with square roots a lot, but other roots have some similar rules. It's not always the same. When you introduce a square root to a problem, what also must be introduced with it? What other symbol? X squared is equal to 4. I put a square root on it. Generally, we get x equals 2, but 2 is not the only number that when squared becomes 4. What's the other one? Negative. When you use a square root, you have to put a plus or a minus on things. Now, that's not true for all roots, for all radicals. It's true on radicals that are undoing powers that are even. If I had something like x cubed equal to 8 and did a cube root, I don't need to introduce a positive or a negative. Because I can do odd roots of negative numbers and not end up in the imaginaries. I can't do even roots of negatives without ending up in the imaginaries. If it is a 4th root, when I do my, or 4th power, when I do my 4th root, the number gets a plus or a minus in front of it. Now, speaking of 4th roots, do you know how to type that into your calculator? In the TI calculator. Actually, in both calculators, the first thing you're going to want to start with is the index. That's what this thing's called, that 4. In the TI graphing calculators, it's under the math button. In the Casio graphing calculators, or the little baby TI calculators, look for your power button. The little caret symbol. Secondary to that should be a little X root button. Again, this is true for the Casio graphing calculators. Okay, I can't get it to focus in. Oh, there it is. And it's true on the little baby TIs. Look for that little X root button. Shift, and then that power button. TI graphing, it was the 5th one down, that X power root. Then type in your 625. The calculator will tell you what's known as the principal root or the principal radical, where it'll only give you the positive version. You have to understand that there's both a positive and a negative. R is positive or negative 5. Now keep in mind that R isn't actually what we're looking for. The thing we're looking for are those numbers that happen in the middle.
10, 50, 250,
When R is a positive or a negative, you've got two options. If R was positive 5, after 2 would come 10, 50, 250, and then after that's 1250. If R is negative 5, same idea, but the 10 becomes negative, the 50 stays positive, the 250 is negative. It goes back and forth from positive to negative. So you got to be careful of that. Okay. We are done right there. I've spoken far long enough. Today's assignment, although broken up into a number of sections, is actually fairly short though. 18 through 21, 24 through 34, that section is the evens, and then 35 through 40.